All right. In today's lesson, we're going to be talking about the classifications of solutions. We're going to be taking a look at equations. We're not necessarily going to be solving a lot of these equations, but instead what we're going to be doing is we're going to be observing these equations, trying to find certain patterns in these equations, and then make prediction as to what type of solution that equation is going to have. But in order to do that, we have to kind of go back to what we just tested on this week, and that is vocabulary terms such as coefficient and constant. Now, if you turn to page 47 in your books, where lesson 7 starts, there is a blank page to the left, and I'd just like you to write down these quick definitions on the blank page next to page 47 in your book. So I'll give you a second to open up your books to page 47. So go ahead and do that. Okay, so on the blank page next to page 47, please write down coefficient and constant. And as a reminder and as a little bit of review, what is coefficient? Well, coefficient is the number in front of the variable. Okay, some examples could be 3x, where the 3 is the coefficient. Could be negative 2y. Again, the negative 2 is the coefficient. It's what's in front of the variable. You could have 1/2 xy squared. And again, the coefficient is just the 1/2. That's what's in front of the variable there. Now, a constant, as some of you may remember, is the number that's by itself. Okay, he doesn't have any buddies, he doesn't have any friends, he's kind of just out there all by himself. For example, in the following equation, or not equation, expression, 3x plus 2, the item that doesn't have a variable next to it is the 2, therefore it is the constant, and it does not have a variable next to it. If I had another equation like 4x plus 5y plus 3/4, again, the constant is the number that's by itself. It does not have any variables attached to it. Okay? So again, go ahead and write these down in the blank pages to the left, because it's very important that you understand what coefficient and constant means in order to classify these solutions that we're going to be working on over the next several minutes. Okay? So now let's take a look at page 47. And what we're going to do for these three problems is we're going to solve each equation. Okay, like I said, we're not going to be doing too much solving today, but we are going to solve a couple of these, so maybe you can kind of see what's going on. So in order to solve this equation, again, draw your line down the middle. We want to get our variables on both sides. I'm going to kind of go pretty quickly here because, again, this is review. So I'm going to move the lower valued variable, which is negative 5x. Oops. Over here, subtract 5x. 7x minus 5x is 2x. Minus 3 equals, all that's left on this side is 5. And then finally I'm going to add 3 to both sides. Well, not finally, but add 3 to both sides. That's going to give me 2x equals 8. In the last step, to undo this multiplication, that's gluing the 2 and the x together, I'm going to divide by 2. Divide by 2, x equals 4. Okay. So that's the first equation. Okay, give you guys a second to catch up there. So now let's take a look at the second equation. Looks kind of similar to the first one. Not exactly the same, but looks similar. Okay, let's take a look at the second one. Draw your line. Okay, so I want to get the variables to the same side. Well, they're both the same. Uh-oh. Well, I guess in that case it doesn't really matter which one I move. Well, let's move the one on the right. So it's a positive 7x, so to get rid of it, I'm going to subtract 7x. So when I subtract 7x from 7x, they go away and they kind of disappear. That becomes 0. That's just going to leave me negative 3 equals 5. Well, that's kind of weird because I know negative 3 is not the same thing as 5, so what's going on here? Well, this is an example of no solution. So there is no solution. We'll talk about that in a minute. Okay, and then finally, let's take a look at problem 3 down here. Again, it looks kind of similar to the first two equations. It's a little bit different, but it looks similar. So again, let's attempt this one, and let's see what happens here. Okay, again, I want to move my x's to the same side. I'm going to subtract x from this side, subtract x from this side. 7x minus 7x is 0, goes away. 7x minus 7x on the other side goes away. What does that leave me? That leaves me negative 3 equals 3. What's going on there? I don't have like an x equals something. I don't have a single solution. And in fact, this is a correct equation. Negative 3 does in fact equal negative 3. Okay? Well, in a situation like this, that means I get infinite solutions. So go ahead and write that down. Okay, so let's take a look at all three of these equations, because if you notice, they're pretty similar. They're not the exact same equation if you look closely at them. Some things are different, some things are the same, but I'm getting different results. Here I get x equals 4. Well, I'm getting an actual solution. If I put 4 back into the equation, it's going to satisfy the equation. Here for number 2, it doesn't make sense at all. I mean, negative 3 can't equal 5, so that doesn't make sense. Well, what that means is there's no value for x that's going to make this situation true. So for example, if I put x equals 3 into the equation, I'm going to get 7 times 3 on the left side, which is 21. 21 minus 3 is 18. And then if I go to the right side, 7 times 3 is 21, plus 5 is 26, and again, that doesn't work out. So this type of problem does not have a solution. There's no value for x I can put into this equation that would make sense. And I know that when I get this result down here, when I get something that doesn't equal something else. So there's no solution there. And then finally, take a look at this number 3. This is, I get a number equaling a number, a constant equaling a constant. So what this tells me is it doesn't matter what value I put in for x, it's going to solve it. It's going to make sense. So for example, let's just say I put 5 in for x. Let's just say x equals 5 here. So if I put that into the left side, that's going to be 7 times 5, which is 35. Let me rewrite it. So 7 times 5 is 35. 35 minus 3. If I do that on the right side, negative 3 plus 7 times 5, which is 35. Okay, and 35 minus 3 on the left side is 32. Negative 3 plus 35 on the right side is 32. So again, I just randomly picked the number 5, put it into the equation, and the left side does in fact equal the right side, and it does satisfy the equation. So I can recognize the fact that when I get a result such as a constant equaling the same constant, what it's going to tell me is it doesn't matter what I put in for x. I'm going to get an infinite amount of solutions. So again, take a look at these 3 different results. Up here, in number 1, I'm getting 1 solution. So go ahead and write this down. In the second equation, I'm getting no solution. Nothing will satisfy that equation. It's like the angry equation. Number 3, infinite solution. It doesn't matter what I put in for x, it's going to work. It's going to satisfy the left side or the right side of that equation. Okay? So let's take a look at the next page. So now, is there a way to predict that type of solution? Is there a way to look at an equation and predict that type of equation? Well, let's see if we can figure out something. Let's see if we can observe something within these 3 equations. So again, I have these equations that we saw on the previous page. So above this, go ahead and write 1 solution. Above the middle one, write no solution. And the far right one, write infinite solutions. So, oh boy, that was a bad. Let's try that again. Solution. Okay. All right. So let's take a look at the no solution one. Let's take a look at this equation first. What do you notice about the equation? Is there anything you can see as far as coefficients and constants go? Again, back to those two vocabulary words that we just talked about. Well, let's talk about the coefficients. I'm just going to abbreviate that because I'm running out of space. So what are the coefficients? On the left side, it's 7. On the right side, it's also 7. So they are the same. Okay, well that's pretty interesting. That might be telling. Let's take a look at the constants. What are the constants? Well, on the left side, it's -3, and on the right side, it's a +5. Okay, so here are my constants here. So they're different in this case, different. So let's now take a look at infinite solutions. Let's take a look at the far right one. Oops, probably should have used the purple in the middle, but oops, can't go back. All right, so what do we notice about the coefficients in, what happened there? Sorry about that. Coefficients in this box. Well, coefficient 7, coefficient 7. So I would say they are the same. What do you notice about the constants? Well, let's write down the constants. What are they in this problem? Constants. I'm missing my S's. Sorry about that. Well, they are, let's see here, it's -3 and -3. So -3. So they are the same. And then finally, let's go back to one solution. Take a look at the coefficients. Again, I'm going to abbreviate. So what are the coefficients in this one? Well, this one, notice, the coefficients are 7 and 5. I would say they are different. And then the constants, in this case, 5 and -3, they are also different. So now, let's take a look at what we just kind of came across here. When we have a one solution, in other words, we end up with x equals something. So I'll write this down here. So x equals a number. That's one solution. X is going to be that number. You notice that my coefficients are different. Okay? So that's important. That means they're not going to cancel each other out. That I'm going to be left with an x. And my constants are also different. Okay? That may not be as important but as the coefficients being different, but we'll talk about that later. Take a look at the no solutions. So no solutions, I now have the coefficients are the same. Okay? And that's important because they are going to cancel. They're going to go away. You're going to lose your variable when the coefficients are the same here. And because our constants are different, and that's all that's going to be left in the problem, that means that something's not going to equal something. So, for example, in this case, -3 will not equal 5. So that's why we don't get a solution for this one. We have different coefficients and different, we have the same coefficients and different constants. And then finally, the third one where we have infinite solutions, this is one where you can put x in for anything. Again, we have the same coefficients, which is similar to our middle column. Okay, that's important because that means our variables disappear and we're left with just the constants. So my 7x and my 7x disappears, but because my constants are the same, I end up getting -3 equals -3, which then tells me it does not matter what I put in for x. It's going to satisfy both the left and the right side of the equation. Okay? Okay, so take a look now at the bottom section here where we have 3 boxes with different equations in each box. And let's just take a look, and we're not going to solve any of these, but let's just take a look and see if we can make any observations here. So let's take a look at this first box. So again, what are we focusing on? We're focusing on coefficients and constants. So my coefficients are the numbers in front of the variables, my constants are the numbers by themselves. So let's take a look at each equation. If you look at this first equation, I notice that the coefficients are, let's see here, there's 3, there's 8, so those are different. -4, -11, that's different. Here I have a half, here I have 5, so I notice that they are different. And then the constants in this box, let's see here, I got 4, -9, -5, 6. They are different. Now again, it's not going to matter so much about the constants in this first box, but it's good to recognize that anyways. So in this case, I know I'm only going to get one solution because my coefficients are different. Which means if my coefficients are different, which means I'm going to have a variable at the end of the problem. So x is going to equal some type of constant. Oops. So I'll just put a number down here. Okay. So again, when your coefficients are different, you're going to be left with a form of x or a variable equaling a number. Now let's take a look at the middle row, middle section. Again, let's take a look at our coefficients and our constants. So coefficients, constants down here. Okay, so my coefficients, here I have 6x, here I have 6x, they're the same. Here I have -15, -15, they are the same. Here I have 5/4 x, here I have 5/4 x, they are the same. So my coefficients are the same. Now let's look at our constants. So here I have 5 and 8, well, that's different. Here I have 12 and -2, again different. Here I have -1 and 1. So they are different. So remember what it means to have coefficients that are the same. That means eventually they're going to cancel out and you're going to be left with no variable. And the fact that my constants are different, that means I'm going to have something like a number equaling a different number. So something like the following, and that can happen. So this is an example of no solution. So there's no value of x I can put into this equation that'll make sense. And then finally, take a look at the last one. Again, coefficient, constants. At least this time I got my colors going here. So take a look at the coefficients. 10, 10, same. -2, -2, same. 9, 9, they are the same, so my coefficients are the same. And now my constants, numbers by themselves. Woo, what's up? -4, -4. 5, 5, 7, 7. So they are now the same. So again, what does that mean? That means since my coefficients are the same, okay, since my coefficients are going to be the same, that means they're going to end up canceling. They're going to end up gone. So you will not have any variables left in the problem. So now that just leaves the constants. Well, that leaves constants that are the same. So you're going to end up with something like 8 equals 8. I have the same on the left, the same on the right, so the statement is true, but now that tells me I have infinite solutions, which means I can put in any number for x, and the left side is going to equal the right side. Okay? So now let's put this to practice here. So, if you take a look at number 4 on the next page, this is on page 49, it says, give a brief explanation as to what kind of solution you expect the following linear equations to have. It says transform the equation into a simpler form if necessary. So that's good. So if we can simplify, we're going to simplify because that might help us identify our coefficients and constants and if they're the same or not. So again, I'm not going to solve this. I just want to see if I can simplify the left side and the right side. So if I look at the left side, I know I can combine 11x minus 9x. So I'm going to rewrite that as 9x plus 15
And over here on the right side, I know I can combine 8 plus 7. So that's going to be 15 plus 9x. So again, what do you notice about the coefficients? Coefficients, they are the same. And then that tells me that they are eventually going to be canceled out, which is going to leave me just my constants, which are the same. So that means I'm going to have infinite solutions. Okay, so go ahead and try 5, 6, and 7 on your own. And when you're done, well, hit pause, and then when you're done, you can start the video again to check your work. So go ahead and hit pause and work on 5, 6, and 7. Okay, so if you look at number 5, all I did was distribute my 3 to get 3x minus 42 plus 1. Then I took negative 42, added 1 to it to get negative 41. And so let's observe, let's see if we can detect what's going on here. Look at my coefficients. My coefficients are different. And my constants are also different. So since my variables or my coefficients are different, that means I'm going to have an x somewhere at the end. Therefore, this is called one solution. Because at some point I'm going to have x equaling a number. Okay, take a look at number 6 real quick. Number 6, I simplified negative 3x and minus 7x to get negative 10x plus 32. Over here I distributed. Did my Angry Birds. Boop, boop. Got negative 10x minus 20. What do we notice? Let's see here. Coefficients are the same. My constants are different. So again, because my coefficients are the same, my variables are going to go away. So what's that going to leave me? Well, that's going to leave me with just the numbers. So 32 equals negative 20. That doesn't make sense. So this is no solution. Okay, because again you're left with something like negative 32 equals negative 20, and that does not make sense. Okay, take a look at the next one. Okay, after simplifying, after doing my Angry Birds, 1/2 times 8 is 4x, 1/2 times 26 is 13, so I get 4x plus 13. Coefficients, well, they're both 4, so they are the same. My constants, 13 and 13, they are also the same. So again, because my coefficients are the same, they're going to be gone. That leaves me with 13 equals 13, which is a true statement. Therefore, I get infinite solutions. So 13 equals 13. Okay? So now look at 8, 9, and 10. This time it's going to be your job to come up with the equations based on what they're asking for. So I'm going to kind of get you started on 8, 9, and 10, see if you can come up with the equation. And you can be as creative as you want if you'd like. So for example, the first one says write 2 equations that have no solution. So again, what does that mean? Well, that means our coefficients will be the same. So whatever equation you come up with, make sure that the coefficients in the end are the same on both sides. And my constants will be different. Okay? So that's no solution. Take a look at number 9. One unique solution. So that means you're going to have x equaling a number. Well, that means basically your coefficients need to be different. And your constants can also be different. Okay, so think about that when you write your equations. And number 10, infinite many solutions. So what does that mean? Well, that means you're going to have something like 3 equals 3 when you're done. So in order to get there, you need to have coefficients that are the same, so they cancel out, and constants that are the same. Okay, so that they cancel out. Okay, so go ahead and try to write your equations for 8, 9, and 10 based on the clues that we just went over there. Okay, so go ahead and pause and work on 8, 9, and 10. And then when you're done, turn to page 51, your exit slip. So this is going to be part of your classwork / homework. You have to complete page 51, 52, 53, and 54. So let me write that down. Homework is page 51 through 54. And again, it sounds like a whole lot of work, but it's actually not too much. Once you understand the coefficients and the constant trick, feel free to look back at your notes. Simplify your equation. I'll have the answer key posted. Please check your work when you're done. Okay? If you have any questions, please see your teacher or come down period 7 or 8 during your study hall if you have time. Okay? Alright, just as a reminder, I'm just going to write this down. You can write it somewhere, maybe on top of your exit slip. So if you want to, you can write this at the top of your exit slip. Again, one solution is when your coefficients are different, constants are different. No solution, again, when your coefficients are the same so they can cancel out, and your constants are different because they wouldn't make sense, they're not going to equal each other. And finally, infinite solution, when your coefficients are the same so they can cancel out, and then you're left with constants that are the same, so your left side equals the right side. So you'd end up with 4 equals 4. The middle one, you'd end up with like 3 equals 5. And the one solution, you'd end up with a variable equaling a number. Okay? So good luck, check your work, and have fun.